Hello everyone, and welcome to our asynchronous lesson on making predictions. In our previous class on Friday, we learned how to create and analyze a scatter plot using our lines of best fit. Remember that line of best fit is an estimate that can be used to make predictions about our data. Today, we're going to be able to make an equation for the line of best fit in order for it to be the most accurate equation possible. In order to do that, we use a process called linear regression. And linear regression uses the data points to calculate the slope and y-intercept of a line that would best fit our data. It's more accurate than estimating like we did last class because there's always some type of human error in estimation. Once we utilize technology, in our case we're going to be using DESMOS to calculate this linear regression equation, we can use this equation to make predictions about our data. These predictions are called interpolating, which is making predictions within our data set, or extrapolating, making predictions outside our data set. I will post a link in our Schoology page where you can go through a little DESMOS tour where we'll actually walk you through how to create this equation, but I'm also going to link a PDF summary at the bottom of our Schoology page, and we're going to be going over it right now. So in order to make a linear regression equation, the first thing we need to do is look at our data set and input that data into DESMOS. So in this example, we're comparing the time in months to an account balance, which looks like it's increasing. And based off of the table and the graph they give me, my line is also increasing. So let's go to DESMOS and type these values in, and it will give us these points on a chart. So in our DESMOS graphing calculator, what we're going to do is we're going to hit this plus sign that says add item, and we're going to add a table so we can get something that looks like our table that was given here. And in our table, I'm going to type each of our points. $0 and $2, $1 and $3, and continue on. I will type all this data in and then get back to you. So I just finished typing in all my data. I paused you guys for a minute. And you'll notice that points started to show up on my graph. I can zoom out and see all those points on my graph. The next thing we're going to do is we're going to add our linear regression equation. So you can add an expression, and what we're going to do is we're going to type in y1, and then you're going to type in this little squiggly sign, which you can either find on your keyboard next to the 1, or here under ABC, it's right here on the bottom. And then we're going to type in mx1 plus b. When you do that, you'll see a lot of numbers pop up here, and a line will be drawn on your graph. This line is your accurate line of best fit. We're going to be talking about these R values in another class, but for today, we're going to be focusing on the M and the B values, because with those, we can write our linear regression equation, the equation for our line of best fit. I'm going to round these numbers to 2 numbers after the decimal place, to the hundredths place. So we'll use M equals 2.08 and B equals 1.59 for our situation. And what we're going to do is we're going to write our linear regression equation. And this is going to be in slope-intercept form. Y equals mx plus b form. And if you notice, in our DESMOS, we found our m and our b. So all we're going to do is we're going to replace our m with 2.08 and our b with 1.59. So my linear regression equation will be y equals 2.08x plus 1.59. After that, we can interpolate and extrapolate data based off of this given equation. So if I look at this first one, using our linear regression equation, determine the estimated account balance for 7.5 months. All we will do is we'll replace our x value with 7.5. So my equation will be y equals 2.08 times 7.5 plus 1.59. And we can just type that in our calculator to figure out the estimated account balance for 7.5 months. When I type this into my calculator, I get 17.19, which estimates my account balance at $17.19, which, looking at my table, would make sense. Somewhere between 7 and 8, my value should be between 15 and 19. And if I look at my graph, at 7.5 months, which will be around here, if I go up, it'll hit my line around 17. Now let's use that same equation to extrapolate some data, which means we're predicting outside of our data set, something above my highest x value. And this time we're going to use this equation to determine the estimated account balance for 15 months. So let's replace that x with 15. And let's type that in our calculator. When I do that, I end up with $32.79, which again, we can go back to our DESMOS. After 15 months, go up, and it looks like I hit at about 32.81, but we rounded our values. So we can use both the graph and the equation to interpolate and extrapolate our data. Let's look at one more situation for another example. I'm going to be using my account balance again, but this time my account balance is going down. So it looks like whoever bank account this is, they're withdrawing money each month. So let's go to our DESMOS and type in our data. So I'm going to go to my DESMOS graphing calculator. I'm just going to get rid of that. And since my x values are all the same, I'm just going to replace each of my y values. So let me get rid of these y values, and we'll replace them with our new ones. And you'll notice my points are disappearing as I'm taking those away. This time I'm not going to worry about the 0.00 after each of the values because I don't necessarily need them. You'll notice that this data looks like it's moving around a lot more than the other data we looked at. The points are further apart and they don't follow any necessarily sort of pattern. So our equation might be a little bit different this time. So let's add an expression, and again, I'm going to type in y1 with the little squiggle sign, mx1 plus b. You'll notice here my line is decreasing, which means my slope is negative. So we'll use those values, an m value of negative 2.42, we'll round that 0.41 up because of the 8 after it, and a b value of 30.27. So if I go back to my equation, again, I can write that in y equals mx plus b form. My linear regression equation will be y equals negative 2.42x plus 30.27. So again, let's interpolate and extrapolate that data. I want to find the estimated number of months for an account balance of 12. So this one's a little bit different this time because I'm not telling you my x value, how many months. I want to find the number of months. I'm given my account balance, or my y value. So this time, let's replace y with 12. And we're solving this time for x. So let's solve our equation by first subtracting 30.27 from both sides. I'll get negative 2.42x equals 12 minus 30.27, which is negative 18.27. And then we'll divide by our negative 2.42 on both sides to get about 7.54 months. I'll just keep it at 7.5. So this linear regression equation estimates that my account balance will be $12 after 7.5 months. And again, if I look at my y values for $12, it looks like it hits the x value at about 7.5 months, which looks like that point. So let's now use our linear regression equation to determine the estimated account balance for 12 months. And this time, we are given the number of months, so I'm going to replace x with 12. So again, I'm going to take this equation, negative 2.42, but instead of x, I'll multiply by 12, and then add my 30.27. And when I type that in my calculator, I end up with 1.23, which means after 12 months, I have an estimated account balance of about $1.23. And if we look at our DESMOS, after 12 months, I see 1.255, which will round to $1.23. And that's our concept for today. So next thing I need you to do is do a little bit of practice using the link that I posted in the directions. If you have any questions while you're working, please feel free to reach out to me by sending me a message on Schoology, and then complete your Show What You Know.